So to start off, the variance of a random value, if you don't remember, we're going to use this symbol, sigma of x squared is the average squared deviation of the values of the variable from their mean. And the standard deviation kind of gives you the average give and take, how far these values are away from their mean on average. Variance, this formula is actually, I'm going to copy it right from your formula sheet that you are allowed and you are given on the AP Statistics exam. It looks something like this. And then we'll talk about it. Okay. So, let's see. When you're looking through this chart, let's copy down that value probability chart from before. For our tails, we had 0 tails, 1 tail, 2 tails, 3 tails, 4 tails. And our probability, there were 1 chance out of here and here, 4 chances from here and here, and there were 6 chances in the middle here. Okay. So our variance would be, the variance, just like before, is the average of the squared deviation of the values from the mean. But we need to make sure we use the weighted values. So instead of just saying we're going to use the number 0, we actually need to use the number 0, take away the mean squared, and then times it by its probability for each one of these, so that it's not like you're going to count one more than the other. You do actually want to count one. This guy is weighted more than all the others, so we want him to be represented more than all the others. So when you're summing all this together for your variance, it would be your value, because remember, these are your x values. This is your x1, your x2, here's your p1, your p2. Take away your mean. Now your mean for this one, I don't think we calculated it, but it would be 2. Square it, and then times it by the probability of getting that. And add it to 1, take away 2, square it, times the probability of that. Now I'm sure we could do one variable statistics in our calculator and do this math for us if we would like. I'm gonna run out of room. Maybe I could kind of cheat on this last one. Nope, I can't. 4 minus 2, and then 1/16. So 4 times, so this would be 4/16 plus 1, so that would be 4/16. This would be 0, so that wouldn't count. 1 times 4/16, and I'm assuming this one's going to also work out to 4/16. So for this one, it should be 1 for our final answer. That's going to be the way it works every single time. But keep in mind too, the standard deviation is basically the square root of all that jazz. And I believe there's a formula for it as well. Oh, looking on there, no, I don't see it. Okay, so that's not something that there'll be a formula for. you'll have to know that it's the square root of that to get the standard deviation. So technically for this one, the standard deviation would be the square root of 1, which is 1. Which kind of makes sense because one standard deviation would be to 3, one standard deviation would be down to 1. It will work a lot different with a different example. So my favorite is really doing examples that are standard deviation would be down to 1. It will work a lot different with a different example. So my favorite is really doing examples that are different than this because this one always worked out to that middle number being the mean also, and it worked out too easy for the standard deviation. So let's say I were to use the 2010 data from the NHL of the number of goals that were scored. So if X is my number of goals scored in the regular season, the chart probability distribution chart would have your goals. There was 0. I believe they went all the way up to 9. And the probability of getting 0 was 0.061, 0.154, 0.228, 0.229. This is not going to work. I'm going to put 4 over here. 0.173, 0.094, 0.041, 0.015, and very small amounts that were actually 8 or 9 goals in the end. Now, a lot of times it will say show it's legitimate. Which means, are all these numbers here that are listed for the probability, are they between 0 and 1? They can be equal to 0 or 1. And is the total 1? And I believe the total is 1 when I added it up. Let me just double check. Yes, the total equals 1. Okay. We can make a histogram, and what you would notice if we were to actually go through all these steps, if we were to make a histogram, the bulk of our information or the bulk of the goals, it's going to be heavily weighted in this area right here. And it's going to definitely be skewed towards that 9. It'll be very much skewed to the right. So just as like a sketch of it for a histogram, it would look something like that. And keep in mind that the mean is pulled into the tail, and the median is always more towards the majority in there. Let's see what other questions could possibly be asked. The mean, before we calculate the mean, can you figure out what the probability of scoring more than or equal to 6 goals? So you'd want to add up 6, 7, 8, and 9 to try to find out what the probability would be. 56. I'm going to check that with a calculator. And keep in mind that it would be different if you were to, for this one, have greater than 6, not with the equal to part. So you wouldn't be counting something like that. You would just be counting those 3, which would, I think, give you just 0.020, something like that. And we want to always write them as decimals or fractions for now. Also, take a minute and try to calculate the mean or the expected value. And keep in mind on this chart, it has both of these things just like this on this formula chart. And this is what is listed. XI, PI. So the sum of the multiplication of the goals times its probability. And you really don't have to do that all by hand if you want to try to do it with the Y variable or the first variable, one variable statistic, something like that. So when you calculate it, double check that when you calculate it, you should get about 2.851 for the mean. And then take a minute and calculate the variance and the standard deviation. I'm getting the variance to be 2.66 and the standard deviation to be around 1.63. And what this means is, on average, the number of goals in a randomly selected game will be away from the mean by about 1.63 goals. So typically away from the mean of 2.8 goals, they'll be up or down about 1.6 goals.